Welcome to section 4.7. Our objectives are I can position figures in the coordinate plane for use in coordinate proofs, and I can prove geometric concepts by using a coordinate proof. Now, you might be scared of proofs by now, but coordinate proofs are actually a little bit nicer because you just make a claim at the beginning. You do a bunch of math, just equations, simple equations like distance formula, and then you make your final claim at the end. So it's a very loosey-goosey proof, and you might like these a lot better. So don't be scared of it. Coordinate proofs are nice. So a coordinate proof is a style of proof that uses coordinate geometry and algebra. So in other words, using the x and y axes, you're plotting points on a graph. So in these coordinate proofs, I recommend using graph paper. First step of a coordinate proof is the position of a given figure, so graph it. And then you can use any position, some strategies. So we're going to talk about how to position things, how to graph things first. So use the origin as a vertex, keeping the figure in quadrant 1. So when you are graphing things, put it here. Don't complicate things by putting it in a different spot, like over here. That doesn't make sense. Use the nice, happy, positive world there. And then center the figure at the origin. So if you're like drawing a square, just put it right there. You don't need to like draw it off on the side. That's just going to confuse things. Put it right on the origin. Use your x and y axes. Center a side of the figure at the origin, use one or both axes aside the figures. It just makes things easier. So like if you're graphing a right triangle, just put it right there. There's your right angle. Beautiful. Okay, you don't need to put it like out in the world. That's just going to complicate things. Just put it at the origin, makes it so much easier. Okay, so position a square with a side length of 6 units on the coordinate plane. So notice that they put it at the origin here, and then they went 6 this way, 6 that way, and then they just connected it because it's a square. And then they put their coordinate points. I do recommend you write your coordinate points. When you're doing your homework, they're going to ask for them, but just get in the habit of writing those coordinate points for each side. You can name them. You can go A, B, C if you want. A, B, C, D. Just make sure you get in the habit of labeling them because you're going to be using those points later on. So this one, position a right triangle. So notice we start at the origin. We're going to use that right angle with leg lengths of 2 and 4. Now, if you wanted to make this side 4 and this side 2, that's perfectly fine. It's still the same right triangle. But it looks like they went 2 this way, 4 that way, and then they just connected it. And yeah, super easy. Okay, position a figure on the coordinate plane and give the coordinates of each vertex. A rectangle with a width of m. Ooh, okay, so this is my width. And we went up m. Now, if you're using graph paper, this can be 2 points, this can be 1 point. I don't care. M is whatever you want it to be. Okay, you're not going to put a number here. You're going to put m because m is your variable. And the length is twice the width. So this is my length. And you're going to go twice whatever you went here. So if you went 2 that way, you're probably going to go 4 this way and just label it as 2m. It's okay to have variables. They want you to have variables in this. And notice we wrote 2 times m as my x because I went 2m that way, twice the width that way. Okay, we have a right triangle again with legs s and t. So we went s and t. If you want this to be s and that to be t, that's fine. Just make sure you recognize your x and your y. And if this is all confusing to you, you can rewatch this video. It's in OneNote. Okay, so do not use both axes when positioning a figure unless you know the figure has a right angle. So if they say that you have a triangle and graph it and you do this, did they say it's a right triangle? Not necessarily. So just make sure you're careful of that. You only graph it like that if it actually has a right angle. So like a square, we know that has a right angle. We can put it on the origin. So we have a side length of 4p all the way around. You notice my coordinates are 4p, so your x, y, so we went 4p this way, 0, and then 4p up, 4p over, and then 0, and then 4p. Just remember your x and your y. If you're not sure how to label these, just remember how to graph. It's going to be the same thing. Okay, so once the figure is placed in the coordinate plane, you can use slope, the coordinates of the vertices, the distance formula, or the midpoint formula. Okay, make note of these. You're going to use slope, distance formula or midpoint formula to prove statements. So if we don't remember, slope is this. Okay, and then distance formula is this. And then midpoint formula is this. And sometimes I write things a little backwards. It does the same thing. It's perfectly fine. There we go. Okay, so those are the three you're going to be using throughout coordinate proofs. So make sure you recognize those and make sure that you're using them. Okay, so here's how to write a coordinate proof. Okay, and there will be one of these on your test, so make sure you understand it. Maybe write it on a note card. You always start with an if-then statement, and it's what you're trying to prove. So if you are trying to say that, okay, so let's say we're trying to prove something is, let's say we're trying to prove that a line is congruent to another line. Okay, well, in order to prove that that line is congruent to another line, we need to show that they're the same length. So we'd probably use the distance formula. So our if-then statement would be if this line, so let's say AB and CD. So if AB is, and CD have the same length, then AB is congruent to CD. Okay, that's if we were trying to prove the lines were congruent. Okay, so it's kind of like our plan. So if they have the same length, then that would mean that they're congruent. Okay, and then we would graph it. We'd put those two lines on the graph, and then we'd show our work. We'd use probably the distance formula in this case because I said the same length. Okay, and then at the end we say therefore, and there's actually, instead of writing therefore, you can put 3 dots like this, a little triangle of dots. It's like an upside down reindeer. Yay! Merry Christmas! The Christmas tree. Therefore, and then you just reiterate this. So therefore, AB is congruent to CD, whatever you're trying to prove. Okay, so I'll show you what this actually looks like. That was just an overview. So write a coordinate proof of this. So given all of that, we're going to prove the diagonals bisect each other. Okay, so we're going to start with my if-then statement, and let's see. Okay, so my if-then statement. So if, okay, so let's see. They're bisecting each other. What can we use to show that? Ooh, if they have the same midpoint. Ooh, okay, let's do that. So if DB and CA, because those are my diagonals, have the same midpoint. Okay, that's my plan. That's saying this is the work I'm going to be doing. Then, okay, then what? The diagonals bisect each other. The diagonals bisect each other. I'm going to write shorthand there. Okay, so this is my if-then statement. This is my starter. Okay, then we graph it, which we already have it graphed. Awesome. And if you want to graph it first and then write your if-then statement, that can help sometimes too. Okay, now we do our work. So we're going to plug in all those points. This is my work. And you don't need to write that. We're just going to use the midpoint formula, and ooh, we see that they have the same midpoint. Okay, so what did we say? We said that if they have the same midpoint, then they bisect each other, and they do. So don't worry about that. You just say, therefore, the diagonals bisect each other, and this is like your proof right here. Okay, I'm going to skip all this. La 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 la. Okay, so here's another one. So given the triangle with this, and so we graphed it there, we're going to prove that this is a isosceles right triangle. Okay, so if, okay, let's focus on the word isosceles first. What would make this isosceles? Two congruent sides, let's see. Okay, so where do you think my congruent sides are? Looks like maybe CB and CA. So if CA and CB have the same length, or if you want to say if they're congruent, if you want to just say that, that's fine too, if congruent. And, okay, so that took care of the isosceles part. So if those are congruent, that would be isosceles. Now what would make this a right triangle? If I had a 90-degree angle, where do you think that 90-degree angle is? Well, judging by my lovely, lovely graph, it looks like it might be right here. So we're going to say and angle C is, well, okay, so how would we show that it's a right angle? Ooh, okay, so let's see. Let's backtrack a little bit because we're going to write our plan, right? So we want to say angle C is 90. Now, 90 degree would be perpendicular, right? So if this is perpendicular to this, using my slope formula, because remember my options, slope, midpoint, or distance. We use distance for the first part. We can use slope for this one. So, and BC is perpendicular to CA. Then, okay, so this is what we did so far. So we said that if these are congruent, using the distance formula, and if these are perpendicular, that would give me an isosceles right triangle. Then triangle ABC is an isosceles right triangle. Okay, so that's my if-then statement. And if you're ever not sure how to get your if, just remember your three that you have here, your slope, midpoint, or distance, and just plan out how you're going to use those. How you're going to use those to prove this. Okay, so now let's start with our CA and CB. We're going to use our distance formula. So let's do CB, distance formula, and you have, let's see, 1 minus 5 squared plus 3 minus 6 squared, and we get 16 and 36, and then we have 52, square root of 52. I'm just going to leave it like that. I'm going to compare it to the other one. So that was CB, now we're going to do CA. Distance formula again, okay, so 1 minus 4 squared plus 3 minus negative 1 squared. Just double checking here. Yep, okay. So then you get 9 plus 16. And I'm realizing now, in case you didn't know, it's my mistake. This should have actually been 9. Good job if you caught my mistake. And this was 25, which is, oh, 5, okay. Which then this is 25 and this is 5. There we go, now they're matching. Okay, so if you're not sure, it looks like it looks like they're equal and you're getting not equal, just double check your work like I did there. Okay, so it looks like CA and CB are congruent. Awesome, okay. Now we have our second step. Find out if these are perpendicular using slope. So let's find our slope of BC. So using our slope formula, so we got 6 minus 3, 5 minus 1, 3 over 4, cool. And then we have CA, slope again, negative 1 minus 3, 4 minus 1, negative 4 over 3. Are those perpendicular? How so? Well, 3 over 4, negative 4 over 3, they're opposite reciprocals, making them perpendicular. Awesome. So we have the sides are congruent, we have those are perpendicular, making a right angle. So we can say that therefore, the three triangles dot things, therefore, ABC is an isosceles right triangle. Okay, and we're just reiterating what we were trying to prove. Ta-da! Super, super easy. Okay, don't overanalyze this. You're just using these three things. The hardest part will be coming up with your if. Your then is always going to be what you're trying to prove. And then your therefore is always going to be what you're trying to prove. So your therefore and then should be really, really easy for you to write down. Okay, and here's just a recap. Wow. Or not. There we go. A recap of how to graph things. If you're not sure, you can watch this video later. You can watch it over and over again. Feel free.